Find the inverse of the function f of x equals 3 plus the log base 3 of x. So in this case, our f has the two-variable equation y equals 3 plus log base 3 of x. And we want to solve for x. So we subtract 3 from both sides to get log base 3 of x. And then we can apply the base 3 exponential to both sides. So if we raise 3 to the y minus 3, that will equal 3 to the log base 3 of x. And 3 to the log base 3 of x is just x. So we get 3 to the y minus 3 equals x, or x equals 3 to the y minus 3. So the two-variable equation for f inverse would be y equals 3 to the x minus 3. Thus, f inverse will take x to 3 to the x minus 3. Now, I'd like to check this work by choosing an arbitrary value for x and evaluating f of x. Now, it's arbitrary, but it will have to be positive since we've got log base 3 of x. So how about if I do log base 3 of 9? Let's go f of 9. F of 9 would be 3 plus log base 3 of 9, and log base 3 of 9 is going to be 2 since 9 is 3 squared, so we get 5. Then if I take f inverse of 5, it should come out to be 9. And in this case, that would give us 3 to the 5 minus 3, which is 3 squared, which is 9. So this gives us some confidence that the inverse function has been computed correctly. Let's go to the second function. F of x equals 1/6 times 3 to the 2 plus x. So our function f has the two-variable equation y equals 1/6 times 3 to the 2 plus x. First of all, in trying to solve for x, I'm going to multiply both sides by 6 to get 6y equals 3 to the power 2 plus x. So the x is trapped in the exponent of a base 3 exponential. To release it, I will apply log base 3 to both sides. So on the left, I'll get log base 3 of 6y. On the right, I'll get log base 3 of 3 to the power 2 plus x. So the right will just become 2 plus x, since a log base 3 undoes an exponential base 3. So to get x by itself, I will subtract 2 from both sides. And therefore, the two-variable equation for f inverse is y equals log base 3 of 6x minus 2, or f inverse of x equals log base 3 of 6x minus 2. So let's pick an arbitrary value for x. This time actually the domain of f is all reals. Let me choose for the x this time the value so we'll do f of, let's do 1. This would be 1/6 times 3 to the 1 plus 2, which would be 3 cubed, which would be 27 over 6, or 9/2. And f inverse of 9/2 would equal log base 3 of 6 times 9/2 subtract 2. 6 cancels to give us a 3 times 9, so we get log base 3 of 27 quantity minus 2. Log base 3 of 27 is 3, since 3 cubed is 27, minus 2 does give us 1. So again, we have some confidence that we did that correctly. This last example is important. We're not only going to find the inverse, we're going to also find the domain this time. And so we start out with f of x equals 2 to the x divided by 9 plus 2 to the x. So here we have a two-variable equation for f would be y equals 2 to the x divided by 9 plus 2 to the x. And the first thing I'll do is I'll multiply both sides by 9 plus 2 to the x. And I wrote an e, I meant a 2. And now I will distribute the y to get 9y plus 2x, 2 to the x times y equals 2 to the x. And now, since I'm solving for x, let me move both of the x terms to the right. So 9y equals 2 to the x minus 2 to the x times y. Now I can factor the 2 to the x out of the right-hand side. 2 to the x divided by 2 to the x is 1, and 2 to the xy divided by 2 to the x is just y. So I get 2 to the x power equals 9y divided by 1 minus y. By taking log base 2 of both sides, I'll release the x. So log base 2 of 2 to the x will equal log base 2 of 9y over 1 minus y. This gives us x equals log base 2 of 9y over 1 minus y. And so the two-variable equation for f inverse is equal to y equals log base 2 of 9x over 1 minus x, and f inverse of x equals log base 2 of 9x over 1 minus x. Now we are asked to find the domain here. So notice that when we talk about the domain for the f inverse, since we're taking log base 2 of a rational function, that the function value 9x over 1 minus x must be greater than 0. But if we think about this as a value for y, we know some things about this function. When x equals 0, the y-intercept would be 0 over 1 or 0. If the x-intercept is 0, so is the y-intercept, and vice versa. Notice that the vertical asymptote is where the denominator is 0, so is x equals 1. The horizontal asymptote is where the quotient of the leading coefficients equals y. So negative 9 equals y. The equation is y equals negative 9. And so our graph has a horizontal asymptote way down at y equals negative 9 and a intercept at the origin. So one branch comes up like this, and the vertical asymptote is x equals 1, and the other branch is down here in the bottom right corner. So when we're answering where is the y value positive, it is from 0 to 1, not including the 1. So it's strictly greater than 0, so the open interval from 0 to 1 is the domain for f inverse.